Here's an example of using a graph to help you determine function values. In the figure below, you see a semicircle centered at the origin with radius 3 and two line segments that complete the graph. You're asked to find the value g of negative 3 by either using points that are already on the graph or creating a formula to use from what you can see from the graph, obtain the formula from the graph. In this particular case, negative 3, 0 is a clearly defined point on your graph. So g of negative 3 means that when you use the input of negative 3, you get the output 0, and that's your function value. Similarly, 3, 0 is a point on your graph, so therefore g of 3 is the output or function value associated with x equals 3. In this case, that is also 0. And g of negative 4.4, I will have to do a little work on that because I see a line segment in the vicinity of x equals negative 4.4, but I don't actually see a clearly marked point. So if I take the fact that this is a line segment, and I have 2 points on this line segment, negative 5, 6, and negative 3, 0. I can calculate the slope. Which is 0 minus 6 divided by negative 3 minus negative 5, and obtain negative 6 divided by negative 3 plus 5, or a slope of negative 6 divided by 2, or finally negative 3. We can use point slope form or slope intercept form to write down the equation of this line segment. If I use point slope, I'll write y minus the y coordinate 6 equals the slope negative 3 times x minus negative 5, which in turn gives me y minus 6 equals negative 3 times the quantity x plus 5, or y equals negative 3 minus 15 plus 6. So when we simplify, we have y equals negative 3x minus 9. Now, plotting the point using the formula, when x is negative 4.4, y will be negative 3 times negative 4.4 minus 9, which gives us a value of 4.2. And you can see from the graph that this looks correct. It appears that as x is negative 4.4 on the graph here, that the y coordinate is roughly 4.2. Alright, lastly, you're asked to find the value of g of 2. G of 2 is even more interesting, if you will, because it is corresponding to the part that's a semicircle. So this is a good review. So let's scroll down a little bit. I need the equation of the semicircle. Going back to an earlier section, we know that if the center is 0, 0, and if the radius is 3, and it's the top half of a semicircle, then the equation should be y equals the square root of the radius squared minus x squared, and that's all under the square root, or the square root of 9 minus x squared. So that's our formula for g of x if the point we're interested in is on the semicircle. So in this case, g of 2 would be the value, the square root of the quantity 9 minus 2 squared, or the square root of 9 minus 4, which is the square root of 5. And square root of 5 is approximately 2.236. So let's look at our graph and pick x equals 2, find the point on the graph and project over, and it appears that our answer looks correct. Now we would prefer to use exact values when we can, so we'll leave this guy as the square root of 5 and the calc pad would appear for you, and you'd be able to type that in, just exactly the square root of 5.